What's up, gang? In this lesson, we're going to be looking at an alternative method for graphing lines by using the intercepts. So I'm going to start by redefining for you what the x and y-intercepts are of a graph. The point at which the graph intersects the x-axis is called the x-intercept, and likewise the point at which the graph intersects the y-axis is called the y-intercept. So if we look at the graph on the right, the point -3, 0 is the x-intercept. And the point 0, 4 is the y-intercept. The x-intercept also has other names that we refer to it as. We sometimes call the x-intercept a root. We sometimes call it a zero. And we sometimes call it a solution to the equation. So anytime you see one of these three words, root, zero, or solution, it's just talking about the x-intercept of that graph. So to find intercepts algebraically, it's pretty simple. To find the x-intercept of an equation, we set y equal to 0, and we solve for x. To find the y-intercept of an equation, we set x equal to 0, and we solve for y. And then once we've found these 2 points, we can actually use those to graph the equation. So here in this example, we're going to practice finding the x and y-intercepts of y equals -2x plus 5. So to find the x-intercept, again, I set my y value equal to 0. And then I'm going to solve that equation for x. So that's 0 equals -2x plus 5. So I'll subtract 5 from both sides to get -5 equals -2x. X comes out to be 5 halves. So the x-intercept of that line would be the point 5 halves, comma 0. The y-intercept we substitute a 0 in for x, and we solve for y. So this would be just y equals 5, so the y-intercept is at the point 0, 5. So what we're going to do now is practice in these examples below, finding x and y-intercepts of each equation, and then once we've found those, we'll use those points to graph the line. So number 1, we have y equals -6/5 x plus 2. The x-intercept of this line is going to be found by substituting 0 for y. So we have 0 equals -6/5 x plus 2. And then we'll solve this equation for x. So I'll need to multiply both sides by -5/6. That's going to give me a positive 5/3 for x. So my x-intercept is at 5/3, 0. Now for my y-intercept, I'm going to substitute 0 in for x. And that just gives me a y-intercept of 0, 2. Okay, so for the graph of this, the x-intercept is at 5/3, 0. It helps if you think of 5/3 as a mixed number. 5/3 would be the same as 1 and 2/3. So this point is going to be between 1 and 2. Oops, not between 0 and 1, between 1 and 2, about right there. And then 0, 2 is here. So the graph of this line, you want to use a straight edge and do the best you can to connect those points and keep the line, again, straight throughout. Mine's not going to be great since I'm doing this freehand, but this would be the graph of that line using the intercepts. Okay, looking at number 2, 4x minus y equals 8. So the x-intercept of this line, we'll substitute 0 for y, and so that gives us 4x minus 0 equals 8, which is just 4x equals 8. X comes out to be 2, so we have an x-intercept at 2, 0. And that would be this point here. The y-intercept, we'll substitute a 0 in for x, so we have 4 times 0 minus y equals 8. That gives us negative y equals 8, so y is negative 8. So we have a point at 0, negative 8, which is down here. And if I could just connect those 2 points using a straight edge again, this would be my graph. Number 3, negative 5x minus 4y equals negative 24. So the x-intercept is going to be negative 5x minus 4 times 0 equals negative 24. Negative 4 times 0 is just 0, so really this is just negative 5x equals negative 24. Divide both sides by negative 5, and x comes out to be 24 fifths. So my x-intercept is at 24 fifths, 0. And let's think about 24 fifths. That's really 4 and 4 fifths as a mixed number, or 4.8. So on the coordinate plane, that would be just to the left of 5, 0, about right here. And the y-intercept now. We'll have negative 5 times 0 minus 4y equals negative 24. So we get negative 4y equals negative 24. Divide by negative 4, and we get y equals 6. So there's our y-intercept, and we'll graph our line. Okay, one more example. 3/4 x minus 1/3 y equals negative 2. Again, the x-intercept, we'll do 3/4 x minus 1/3 times 0 equals negative 2. That's just going to give us 3/4 x equals negative 2. To solve for x, I need to multiply by the reciprocal, 4/3. And the x-intercept comes out to be negative 8/3. So we're at the point negative 8/3, 0. Negative 8/3 is the same as negative 2 and 2/3. So we'll be to the left of negative 2, between negative 2 and negative 3, a little bit more than halfway. And then the y-intercept, we'll substitute 0 in for x, so 3/4 times 0 minus 1/3 y equals negative 2. So we get negative 1/3 y equals negative 2. We need to multiply by negative 3 to cancel out the negative 1/3. Negative 2 times negative 3 is positive 6. So our y-intercept comes out to be 0, 6, which is here. And this is the graph of our fourth line. Okay, so this is just, again, an alternate way to graph lines. Okay, the other way is what we did in the first video, to transfer your equations to slope-intercept form. And that actually gets you a little bit more accurate line, because it allows you to right away identify the slope and get more points on your line. But the intercepts method that we've just done is a really quick way if you need to see, again, where the intercepts of a line are, to do that and get a good idea for what the line looks like. Okay, so if there are any questions over this video, make sure you ask those. And until I see you again, folks, have a nice day. You're all wonderful people. Take care.